All right, so many of you that are here are wondering what it is, why, but you know that there might be a little bit about engineering that you like. Maybe some of you have an uncle, an aunt, possibly a dad, mom, that's an engineer. Some of you don't have a clue of what actually an engineer does or is. And so this kind of gives you an overview. And if you talk to engineers, which I've talked to a lot of them in my years teaching, because I've had a lot of parents, not any two jobs really are the same. And so to look for an overall definition of engineering, you go to this. Oh, not this one. This one. Engineers' application of math and science principles to better improve life. And that is why this class isn't for you to become an engineer. This class is to help you see where math and science is used. The reason why we are looking at you taking Algebra 2, Pre-Calc later on, is for engineering, architecture, different science fields, where that math is used, accounting, okay? So please write this down. John, why don't you come up to this table here? I want everybody to have a table to write on, not me. Okay? We can. All right? Application of math and science to better or improve life. Anything that enhances human potential is considered technology, right? So someone had to create that. Now, do they have to be engineers? No, but many of them are. Okay? And they're using math and science. And I feel the difference between a good engineer and a great engineer is creativity, imagination, being able to see what is possible. Very few engineers that you know of, that you have heard of, just use math and science. Okay? They also use the creativity, their imagination, their spatial awareness. All right, engineers. What is an engineer? Don't have to write this down, because we know the definition of engineering, right? An engineer is a person who is trained to use technology and science to solve practical problems. Okay? The difference between this classroom and the science classroom and the science classroom over there.
Good morning, SHS. Your rightful ruler is back, and I was just coming to tell you happy birthday to Laura Pombach. Have a great day.
All right. And we don't care why. Science cares why. We want to know, okay, that's cool. What can we do with it to create something to help solve problems? Does that make sense? Science cares why. We don't. Now we want to take it and not discover why it is, but how can we use it to make a new product, to make something more efficient, to make a car that can move on water, okay, that can be powered by water, okay? That's what engineers do. You have this PowerPoint. One of your assignments is going to be to go to greatest achievements and fill out the worksheet. and engineering girls. So you don't have to write this down. You have this PowerPoint in Google Slides. Sam, do we not have a chair here? Take mine. Okay, and there's a desk back there, table back there. There's a table spot right here. I want everybody to be able to write on something. Okay. Now, I do want you to write this, because what do? They research, they develop, they design, they supervise, and they manage. Okay? And many of these, so when comes back to what I first talked about, is an engineer, you talk to one engineer and what they do does not mean that that's the only thing they do. Or is that they're one, oh, I'm an engineer. Oh, okay, so you do this. No, not engineer, so there's a lot of different things out there. Okay, but they can be broken down into 5 main topics: research, develop, design, supervise, and manage. This is where the money is. It's also where the headaches come. You know, I talked to a lot of 40, 50-year-olds, and they worked as an engineer for a long time, and now they got into a supervision role. And they go, you know, I'd rather go to work and work on trying to make products better, try to make a new medicine, try to do this, instead of supervising people that are doing that. Because that was fun. This stuff was fun. This stuff is, now I'm in charge of people doing that. And some people like this. Okay? So, this is going to go through, and I'm going to kind of rattle through these because those are each one. So what is research? Basically, you're using scientific principles in discovering an application of a new knowledge. Here's the difference: that will have commercial or economic value. Write that somewhere. Keep that in your noggin. Here, I need to steal a chair. I'll be right back.
Write this down.
Yeah, why don't you sit right next to Cole there? Right now. Okay. Yep. Okay. And so the science, again, I talked about this. Wants to know why? We want to know if it has commercial or economic value. Okay, can it make money? Develop existing or invent new products. Discover truths about a subject. Research. Okay. Next one, development. So once that research is done and now how can we take it and develop that into a product that has commercial or economic value? Okay, so developing is taking that knowledge and using it to solve a problem, to make human life better. Design. And all of these kind of are fuzzy, like there's no line, like, okay, you're in development, oh, I'm in design, and there's a big line here. No, there's parts that go over on one side and come on, and so it's not like it's a definite divide, but designing new products, okay? And here's a picture of a engineering notebook. So, how design a manufacturing plant. All right, supervise. We know what that is. It's being in charge of people. Okay, works with technicians, mechanics, laborers. Sales. A lot of times they want engineers. working in sales because they're trying to sell things. You have to have a basic knowledge of that subject. And I got a friend of a friend, because they were both went to Milwaukee School of Engineers, and he went into sales, and my buddy was mechanical. They're both mechanical engineers, one in the sales and the other one mechanical. The guy who went into sales is making more money, okay, than the one that's developing and doing that. Because a lot of times, you know, you got to be able to, for a company, you got to be able to make money, right? And if you can't sell the stuff, it doesn't matter. And he became a great salesman, and that is why, with his engineering background, he's able to sell it. Management. All right. Again, this is in classroom. The next one is you're going to use engineering disciplines. Does this slide look familiar? It should, right? So I already showed it to you. All right, write this down. These are the big four types of engineering: chemical, civil, electrical, and mechanical. Guarantee it will be a test question. Will be a test question for me, and it will also be a test question on the main test that you'll be taking at the end of the year to get college credit. Other disciplines are a derivative of these, or a combination of two. Let's say biomedical, okay? Depending on what aspect, what you're working on. But let's say you're working on a defibrillator for a heart. I would say that definitely be electrical engineer, right? Because you got to be able to create that. But also, if there's moving parts to it, maybe it's a can as well. So we got chemical, civil, electrical, mechanical. Try to think of a way to help you remember these. Make an acronym, CCEM, or switch them around. It's not an order, okay? All right, chemical engineering. Examples of what they would do is for new fuel for rockets, reactors, medicines, vaccines. Okay, they work in 3M hires a lot of chemical engineers, and their job is to create new materials, new plastic, new tape, ways that tape will hold, more environmentally friendly tape to, I'm stuck on tape, to sandpaper, to what else was I, different ways of cutting, okay? And the reason why they want chemical engineers is because they're messing with different chemicals, researching with different chemicals to try to create new products. At 3M, 10% of your time, which in a work day would correlate to half a day, or work week would correlate to half a day, you get to research what you want. So about 4 hours every week, you are to be researching, working on an idea that you want, an invention that you want to create to get a patent. Okay? Chemical engineers use different chemicals to try to create new materials, new products, new medicines. Okay? Civil, and they threw construction engineering, civil and construction engineers. This is plan and design, supervise construction of, so there'll be facilities in both public and private sector, but these are big projects, okay? How Somerset's sewage is designed by a civil engineer. The infrastructure into Stillwater's new bridge was a civil and construction engineer. Okay. Buildings, highways, transit systems, new dams, and how that all works together. Hello? Yep, I'll do that. Yep. You got your lab scheduled 5 and 6 for today. For a project either way.
Yeah, I'm also class
What?
right now too. Oh.
Yeah, I know you because you're here. So, and then highways, transit systems from railways to different ways of getting them out. Okay, civil and construction. Airports. How many of you have been, when you've been in an airport, have been like, holy smokes, the organization for this. Okay, whoever designed and created that, okay, and it's probably not one person, I guarantee it, but it's a company, there's a civil engineering company, okay? You know, and you're like, okay, this isn't a fun, it's not a sexy profession, but the treatment and distribution facilities for water. One of the main reasons third world countries have the infant mortality, have people dying, is right here. You know, if you want to save the world, become an engineer, work on treatment distribution facilities for water and collection treatment of wastewater, and then go to these third world countries and help them. Because there's millions of people dying every year because we're not able to do this, don't have the money to be able to do this. We have an overpopulation, and we need to be able to get rid of the poop, basically, in a clean, effective way. Electrical electronics engineering. They're dealing with the electronics behind it. You ever seen when you take something apart, that green board with all the different things that look like a little tiny city? Okay? Electrical engineer designed that. Working on, and that's from small stuff. And electronics keeps getting smaller and smaller and smaller. The steering wheel of a car is not mechanical, it's electrical. You are turning a wheel, and there's sensors that sense that wheel and are turning the tires. There used to be a mechanical tie rod, that's not the right word, steering wheel rod that went to a tie rod that turned the wheels. But it used to be a mechanical, not anymore. It's completely electrical in your newer cars. More and more things are becoming electrical. You look at your phone, that is designed and created by electrical engineers. Okay? And software engineers, but all the way to big, huge things like electrical generation plants. Okay? Solar cells. I mean, the options are endless. And then mechanical. This, to me, would be the cool thing. Let's see if there's one more. Yep. It is whenever you're dealing with gears, sprockets, movement, it's mechanical. And now there's combinations of these all the time where electrical uses, works with gears and pulleys and makes things move. And so then it takes electrical and mechanical engineer. Okay? So does everybody kind of understand the main four, what they are? All right, now there's more. I'm just going to keep clicking through all of these. Don't have to write them down, but I want you just to kind of just look and imagine what it would be for you to do these jobs. Hello. All right, thank you. Bye. Let's see, you're also on for today. All right. Aeronautical deals with airplanes. Okay. Aerospace deals with outer space engineering. Okay. Unless if let's say you say, no, I want to go be working on things for outer space, then I would say, okay, there's look up for a school, look to where to go that. If you're like, you know what, I just like math and science, I like creating things, I don't really know exactly what, become a mechanical engineer, become an electrical engineer, and try to get a job at an aerospace place. Because you're going to be the big four is where I would recommend getting a degree unless you know you want to work into aerospace. Okay? Not found on Earth. So you're talking about the Mars rover. Those are aerospace engineers. Architectural engineering. Okay, there's many good degrees in architectural or agricultural engineering. How are we going to feed this planet? Okay, and don't need to write this stuff down. Okay, just that I want you to know that there's a degree out there, agricultural engineer, architectural engineers. Architectural engineers and architects are different. Okay, architectural engineer works more on strength of materials. Are you able to use that to hold a roof up? Things like that. Just keep that right there, Sam. Where an architect is doing both. They work with architects, and their job is to usually do the math and science behind how big a beam do we need before we can have a support? How big a roof can we go? If we have the main difference is an architect is concerned for aesthetics. An architectural engineer's job is to make sure that the roof holds and it doesn't leak. An architect would argue that that's also their job too. But I love this slide. All right, automotive engineer. And it's actually a good one. I mean, the reason I like it is because it's such a small little dinky little backhoe, which I would love to have in my garage right now.
Looks like one of those things at the playground that you just.
It does, yeah. But when you think of automotive engineers, everybody's thinking of cars. And there's a lot of different products out there, from four-wheelers to side-by-sides to little tiny backhoes that are designed and created by people. Okay. My buddy had a backhoe, but you didn't sit on, you stood, and it had where you could put a backhoe and be able to dig out. And it was about that big. Okay, and he used it in, bringing up shrubs and stuff, people's yard where they didn't want to have a big backhoe in. Okay. All right, biomedical engineering. And this has been a huge field because there's been lots of money and designing new products. If you look at Boston, all the different, especially around the Twin Cities area, all the different Metasize and different companies that are creating biomedical equipment, biomedical engineering. But again, computer engineering, you got two types, hardware and software. I said I wasn't going to talk. The largest consumer of computers today, the automotive industry. There's over 1 million lines of code on average in a vehicle. Industrial, how can we make things more efficient? Design, improvement, installation, integrated systems, people. All right. All right. Let's end this. So, your assignment. There's a worksheet in Google Classroom.